Have you ever stopped to think about the invisible force that's running, well, pretty much everything in your life? I'm talking about the traffic lights on your commute, the apps you scroll through on your phone, the shows you binge watch at night. It's all powered by software. But where did this powerful, silent architect of our modern world actually come from? The story is a lot longer, a lot stranger, and way more fascinating than you probably think.
So in this explainer, we're going to trace that secret history. We'll walk through it in 6 parts. We'll start with an idea that existed before computers were even a thing, then jump to the era of giant mainframes and shared code. We'll hit the PC revolution, the move to online services, and then get into the really wild stuff, when software started to learn, which leads us right where we are now, staring into a very intelligent and maybe a little uncertain future.
So that's the big question, right? How did we get from mechanical calculators to code that can literally create art? Where did this invisible thing we call software actually begin? All right, so our story doesn't start with silicon chips or blinking lights. Nope. It starts with paper and ink. This is the prehistory, a time when people were dreaming up the idea of a program for machines that were completely theoretical.
And this is what's so wild. The idea of software is way older than any machine that could run it. Get this. In 1843, Ada Lovelace writes the world's first algorithm, a program for a machine that didn't even exist. It took almost another century, until 1936, for Alan Turing to lay out the theoretical blueprint for all modern computers. And only after that, in 1941, did Konrad Zuse finally build the first machine that could actually execute a program. The dream really did come long before the reality.
I mean, Lovelace's vision was just astounding. She wasn't just thinking about crunching numbers. She saw that if a machine could manipulate numbers, which are just symbols, it could theoretically manipulate any symbols, like musical notes or artistic patterns. She basically imagined computers creating art and music more than 100 years before it was actually possible. Incredible. Okay, so let's fast forward from those early dreams to the first practical era of computing. We're in the 1950s and 60s now. Computers are massive, the size of entire rooms, and the culture around them was, well, probably not what you'd expect. It was surprisingly open and collaborative. So here's the deal. These mainframe computers were enormous and insanely expensive. Nobody could afford their own. So the solution was something called time sharing. A company would have a bunch of dumb terminals, basically just a keyboard and a screen, all connected to one giant central computer. All the processing, all the data, it all happened on that one machine. Sound familiar? It should. It was basically the grandfather of what we now call cloud computing or software as a service. And the whole vibe of this era was completely different. Software wasn't really a product you'd buy. It just kind of came with a giant expensive machine. The source code, the actual human-readable instructions, was shared freely. People formed user groups to trade code, help each other fix bugs, and build new features together. It was this open, academic, almost communal way of doing things. But that collaborative spirit wasn't going to last. The late 70s and 80s roll around, the personal computer arrives on the scene, and suddenly a huge fight breaks out over the very soul of software. Was it a shared resource for everyone, or was it a product you had to pay for? And this quote from a young Bill Gates in 1976, it just captures the whole shift perfectly. He saw all these computer hobbyists copying and sharing his software for free, and he was not happy. He basically wrote this letter saying, hey, this isn't collaboration, it's theft. This was the moment software stopped being just a tool that came with hardware and started becoming a product, something you buy in a box. And just like that, you had a major clash of ideologies. On one side, you've got this new proprietary model. The code is a secret, and you can't change or share it. But that sparked a huge countermovement, led by an MIT programmer named Richard Stallman. For him, free software wasn't about being free of charge. It was about freedom, about liberty. He believed everyone should have the freedom to run, study, share, and improve the software they use. Now, to protect those freedoms, Stallman came up with something truly ingenious called copyleft. It's this clever legal hack that completely flips copyright on its head. Instead of using copyright law to stop people from sharing, copyleft uses it to guarantee they can. It basically says, you can use my code for free, but whatever you build with it has to be free and open too. It was a brilliant move to keep that collaborative spirit alive. So that battle between proprietary and free software really defined an entire era. But then, the internet showed up and changed the whole game again.
And funny enough, it took us right back to that old time-sharing idea, but this time on a global scale. We went from buying software in a box to just renting it online. The first attempt back in the late 90s was something called the ASP model. And honestly, it didn't work too well. It was slow, clunky, and couldn't really scale up. The model that did work, the one pioneered by companies like Salesforce, was software as a service, or SaaS. The big difference was that SaaS was built for the web from the ground up. It used something called multi-tenant architecture. Think of it like one big, efficient apartment building serving lots of customers, instead of building a separate house for each one. And how successful was this model? Well, in 2014, the software giant SAP paid $8.3 billion for a company called Concur, which had switched from selling software on floppy disks to the SaaS model. That was the moment everyone realized that renting software online was the future. Okay, so software became a product, then it became a service. But this whole time, there was a deeper, more ambitious quest going on in the background. The dream of creating software that could actually think. And let me tell you, it was a long, bumpy road to get to what we call AI. For the longest time, there were two main approaches to AI. The first was symbolic AI, or good old-fashioned AI. This is where humans try to write down every single rule for being smart. It worked great for closed systems like chess, but it totally failed when faced with the messy, unpredictable real world. The other idea was connectionist AI, which was inspired by the human brain. Instead of writing rules, you build these artificial neural networks and have them learn patterns by looking at tons and tons of data. For decades, that first rule-based approach was dominant, but it just kept hitting a wall. The hype never matched the reality. The problems were just too complex. You couldn't possibly write enough rules. This led to a period of total disillusionment known as the AI winter, where all the funding and excitement just dried up. So what ended the AI winter? Well, two things, really. A massive explosion in computing power and all the data being generated by the internet. Suddenly, that old connectionist idea of building a digital brain was actually possible. And that's where deep learning comes in. By using neural networks with lots and lots of layers, deep networks, software could finally teach itself to do complex things, like recognize a cat in a photo, just by sifting through millions of examples. And that incredible breakthrough brings our story right up to this very moment. We now have software that can't just calculate or connect people, it can actually create. So, what does that mean for us? Where do we go from here? The tools you see everywhere now, like ChatGPT, are called large language models, or LLMs. Under the hood, they're a really advanced type of deep learning. But at its core, an LLM isn't really thinking like a human. It's basically an incredibly powerful prediction engine that has analyzed a huge chunk of the internet to get really, really good at guessing what the next word in a sentence should be. But for all their amazing abilities, these systems have some huge challenges. They can hallucinate, which means they just make things up and state them as fact. And because they learn from us, they can easily pick up and even amplify our own biases. And maybe the biggest issue is that they're often a black box. We can see the answer they give us, but even the people who built them can't always explain exactly how they got there. And that leaves us right here at this really pivotal moment. The history of software has been a story of evolution. It started as an abstract dream on paper. Then it learned to calculate for us. Then it learned to connect us all. And now it's learning how to create in ways that make us question our own definitions of creativity and intelligence. So that leaves us with the ultimate question. What on earth is it going to learn next?